this video. So here I am solving the 60 questions of KCET, Karnataka CET 2018, right? So in this video we are going to see 5 questions, and the first question is 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel, right? Which reagent is left in excess and how much, right? So what they are doing, they have taken this magnesium and they are burning with what? Oxygen, and they are getting what? On heating condition it forms what? Magnesium oxide, right? So here one magnesium is there, 2 oxygen, but here only 1 oxygen. So let me balance it by dividing it into half, right? So it means what? 1 oxygen it is. 1 by 2 into 2 is 1, right? So this is the reaction, we have to write it, right? So whenever you want to solve such kind of problems, 1 gram, 0.28 gram, right? Stoichiometry, you should first balance the given reaction. So this is the balanced chemical reaction, right? So what we have to do, first step is balanced reaction, we have to write balanced reaction. So this is the balanced reaction. Further what we have to do, see, so here stoichiometry is what? Here magnesium, let me change the color of the pen so that you can easily remember. So stoichiometry of magnesium is 1 and stoichiometry of oxygen is what? Half. These things you have to remember, because they have talked only about what? Magnesium and oxygen, right? So it will take little time, but no problem, we shall understand and write, right? So see, so first question is what? Which reagent is left in excess? Which is excess, we have to find it. How to find? Easily we can find, right? So here it means what? Stoichiometry is 1 means it has got 1 mole of magnesium is reacting with what? Half mole of oxygen. So 1 mole of magnesium I have written below magnesium, and half mole of oxygen I have written half mole below oxygen, right? And we know that 1 mole of magnesium means it is what? The weight of magnesium, it is 24 gram, right? 1 mole of magnesium means it has 24 gram of magnesium, and half mole of O2 means what? Half of 1 mole, we know oxygen, O2, molecular weight is 16, 16 to the how much? 32. So 32 into half, 1 mole means 32, half mole means how much? Half of 32, that will be almost equal to what? 16 gram. Are you getting? 24 gram of magnesium is reacting with 16 gram of oxygen in the stoichiometry balanced reaction, right? But to find which one is reacting in excess, what we can do, let us take, they have given here in question, they have given that 1 gram of magnesium is reacting with 0.28 gram of oxygen, right? So to find which is excess, let's what to do, 1 gram they have given, molecular weight of magnesium we know that is 24, divided by 24 we will get moles, moles divided by stoichiometry. What is the stoichiometry here? It is 1, right? 1. So that is nothing but the value which will tell whether it is excess or less, right? So here it is like 1 divided by 24, because 1 gram 24, how it came? 1 mole of magnesium is 24, so 1 divided by 24 mole per stoichiometry. Stoichiometry is what? 1. For magnesium it is 1. What I am telling, mole per stoichiometry coefficient, if it is less, then that is in limiting, that will be, if mole per stoichiometry value is less, then that is the limiting reagent, that is what? Limiting reagent. If mole per stoichiometry is more, if mole per stoichiometry constant is more, then that value, if it is more, then that will be in excess, right? So how to calculate mole? So given weight I have taken 1 gram, because they have given 1 gram of magnesium divided by its atomic mass, that is 24. So it is nothing but the mole divided by stoichiometry is 1. How it came 1? Because in balanced chemical reaction magnesium behind stoichiometry is 1. So it is value is 1.1 divided by 24. Same with oxygen we can do. So how much weight they have given? Oxygen they have given 0.28 gram, right? Let us gram, 0.28 gram divided by molecular weight, how much it is? For oxygen it is 2, right? 16 to the 32. Weight divided by molecular weight gives what? What it will give? It will give mole divided by what? Stoichiometric coefficient, that is half. So it can be solved like this, 0.28 divided by 32 into 2 divided by 1, right? So 2 ones are 2, how much are 2 on the 2, 2 6 are 32, right? So it can be done like this. So here 1 by 24, and here how much it is? It is 0.28 divided by 16. So this is very very small. This 0.28 divided by 16 is less, whereas 1 divided by 24 is what? More. Since 1 divided by 24 value is more, so it is excess, and 0.28 divided by 16 is less, so it is what? Limiting reagent. So it is what? Limiting reagent. So they have asked us to tell the excess, which reagent is left in excess. So excess, we got this is the more value, so excess is what? Magnesium is the excess, and oxygen is the limiting reagent. So our answer should, the excess metal is what? Magnesium is the in excess. So in option, if we see A, B, C, D, here O2 they have given in C and D, so this is the wrong option. So we are left with what? Option A or option B, right? So which is excess? Magnesium is excess, right? So if I want to summarize it, how to summarize? In a, if in a given balanced equation, first we have to balance. So this is the balanced equation. See, 1 magnesium, here also 1 magnesium, here 1 oxygen, because half into 2 is 1, here also oxygen. In a balanced reaction, right? In a balanced reaction, mole divided by stoichiometric coefficient. Stoichiometric coefficient means it is 1 here for magnesium, and oxygen it will be half. If its value is less, then that reagent will be limiting. If the value is more, then that reagent will be what? Will be in excess. So we found out that the excess metal was what? Magnesium, whereas oxygen was limiting. So they had asked the excess, so magnesium will be the excess. And next question is, we have to tell which reagent is left excess and how much. So quantity we have to tell how much excess it has left out, right? So again, if I want to solve, it can be easily solved. See, so in this only reaction, let me write it again. 1 mole of magnesium reacting with half mole of oxygen gives magnesium oxide. So we have to tell how much excess it has left, magnesium, right? So how much excess? See, I told 24 gram of oxygen magnesium if I take, so it will 32 into half, it will be what? 16 gram of oxygen it will react to form magnesium oxide, right? 24 gram of magnesium reacts with 16 gram of oxygen to form magnesium oxide. But let me take only 0.28 gram. 0.28 gram. So what happens? 0.28 gram of oxygen needs how much magnesium? That we have to calculate. So I have taken it as X. So simply this divided by this divided by this, let it put as is equal to. So X is equal to what now? Cross multiplication, 24 into 0.28 whole divided by what? 16. So 2 ones are 2 twos are 2 ones are 2 eights are 2 six are 2 fours are 2 twos are 2 threes are 2 ones are 0.14. 3 into 0.14 will be almost equal to how much? 4 threes are 12, 3 ones are 3, 4, 0.42 gram, right? So this much has been consumed. Are you getting what I did? 24 gram of magnesium if I take, it will do how much it will take? It will take 16 gram of oxygen. Are you getting? 24 gram of magnesium needs 16 gram of oxygen. If I take 0.28 gram, how much magnesium is required? 0.24 gram of magnesium is required. But they have taken how much gram? They have taken 1 gram. Right? Are you getting? 1 gram. So it is excess. So they have taken 1 gram of magnesium, but the requirement is how much? Only 0.42 gram. Right? So how much excess it has left? So minus. So they have taken 1 gram, but requirement is 0.42 gram. So just I will minus it. So if I minus it, it is 0, 9, and this is 10. 10 minus 2 is 8. 9 minus 4 is 5. 0.58 gram of excess magnesium is left. Are you getting? So see, answer should be what? Magnesium is the excess metal, and how much it is left? 0.58 gram. So here option B, you can see magnesium is the excess metal and it is left out to be 0.58 gram. So this is the correct option. So this problem is simple only, but you should know that chapter 1 of PUC first year, that is some basic concept of chemistry, right? Only then you can solve it, mole concept and all, right? Easy question. So coming to the second question, the orbital nearest to the nucleus is. So one of the simplest question. So see here, atom means what? Atom will be having nucleus which contains what? Neutrons and protons, and electrons will be revolving around the nucleus in a orbit, right? In a orbit like this, right? So here n is equal to 1. This is first orbit. It is also called as K shell. Here n is equal to 2. This is second orbit. This is called as L shell. And third orbit, n is equal to 3. It is called as M shell. Right? Like this, K shell, L shell, M shell, N shell. Like that it will continue. Right? So they have told orbital nearest to the nucleus. So this is what K shell. Shells are nothing but orbit. There is lot of difference between orbit and orbital, right? So these are orbit. Shells are nothing but the orbit, right? So first we have to see which orbit is near. First orbit is near, second orbit is near, third orbital, first orbit is near with these three, right? So here we can see, here it is 4f, A, B, C, D option. If we see, it is 4f, here n is equal to 4. It is 5D, so n is equal to 5. Here it is 4s, so n is equal to 4. And D, here it is 7p, means n is equal to 7. So which is the nearest orbital? N is equal to 4 should be nearest, because 5 and 7 will be away from the nucleus. So we have to see between now 4f and 4s, right? So these two options are left with. And we know that always in an orbital, s orbital will be nearer to the p orbital compared to p. Then p orbital will be nearer to the nucleus compared to d orbital, and d orbital will be nearer to the nucleus compared to f. So s, p, d, f, this is the order. Are you getting? So between 4f and 4s, here also n is equal to 4, here also n is equal to 4, but s will be nearer compared to f. So answer is 4s. So 4s is the answer. The orbital nearest to the nucleus is 4s orbital within this 4, right? So this is the second question. Answer is third one, right? Talking about third question, which of the following is correct order of radius, right? Radius order. Always you remember whenever we talk about radius, right? So you should know that, see, I have aluminum metal, right? Aluminum metal. If I give some energy, what energy? Amount of energy supplied to remove outermost electron from a neutral gaseous atom, right? If I take this aluminum in neutral gaseous state, which is isolated, if I supply that energy to remove outermost electron, that energy we call it as ionization enthalpy. So it becomes Al plus. Again I will supply energy, I will remove one electron, it becomes Al2 plus. Again I supply energy to remove one more electron, it forms what? Al3 plus, right? So if they ask to compare the size of Al plus, Al2 plus and Al3 plus, you should remember that always neutral atom Al will be having greater size compared to Al plus, compared to Al2 plus, and compared to what? Al3 plus. The reason is, see, aluminum means how many electrons? 13 electrons, right? Sodium, magnesium, aluminum, yes, 13 electrons. If plus becomes what? It has 13 electrons will be there, right? For aluminum. And how many protons will be there? Again 13 protons will be there. 13 electrons and 13 protons. If I remove one electron, so number of, it becomes Al3 plus. Al3 plus will have how many electrons? 12 electrons, but number of protons will be what? 13. So protons will be attracting these electrons, outermost electron. So here see, 13 electron, 13 proton, size will be big. As soon as one electron goes, number of protons increases, so effective nuclear charge increases, because protons are present in nucleus, right? So it will pull those electrons very tightly, so size decreases. So aluminum size will be more compared to Al3 plus. Again if I remove one electron, it becomes 11 electron, 13 protons. Again it will pull those electrons very tightly, because of which size decreases. So this is the order of what? Cation. If I wanted to talk about anion, see, if I have oxygen here, I will put one electron. What that energy released is called as electron gain enthalpy. What is electron gain enthalpy? Amount of energy released when an electron is added to the neutral gaseous isolated atom, right? So it becomes what? Oxygen minus. Again, if I put one electron, it becomes what? O2 minus. If I compare the size, see, the O2 minus will be bigger compared to O minus compared to O. Why that is so? See, oxygen, what is the atomic number of oxygen? It is nitrogen, oxygen, 8, right? 8 oxygen. Atomic number is 8. It means what? 8 electrons will be there and 8 protons will be there, right? O minus means what? I am adding one electron, so it becomes 9 electron and 8 protons. See, since electrons are added in the same orbit, because of its repulsion size increases. So size of O minus will be greater than the size of O. Why that is so? Because of electron repulsion. But here see, number of protons remains same. So O2 minus means I am adding one more electron. I am adding what? I am adding one more electron. So it is what? One more electron means 10 electrons it is. 10 electrons means, but number of protons remains same. So more electron repulsion, hence size will be more. So order should be always, you should remember, star mark you make it, anion size will be always greater than neutral atom size. Neutral atom size, and it will be greater than cation size. Cation size. If they asked you to compare the size of O2 minus, F minus, right, neon, sodium plus, magnesium 2 plus and aluminum 3 plus, see, anion will be of greater size compared to neutral atom, that is neon, which will be of greater size compared to cation, C 2 plus, like this the size. It is the order of what? Size, right? So here we can see that, see, in option D, Al3 plus is greater than Mg2 plus. Wrong. Always Mg2 plus will be greater than Al3 plus, and anion will be highly greater. So this order is wrong. F minus O2 minus, C, O2 minus as negative charge is more on oxygen, its size should be greater than fluorine, but this is also wrong. And here cation is greater than anion, that is also wrong. So correct option is A. See, anion is greater size compared to neutral atom. Neutral atom is greater as that of size of cation. So option E is the correct option. So this is the third question. Right. Talking about the fourth question. Intramolecular hydrogen bonding. Right. First you should know hydrogen bond is of two types. One is intermolecular, other one is intramolecular. And first you should know hydrogen bond happens between oxygen, nitrogen and what? Nitrogen, oxygen and halogens, fluorine, that to fluorine, it should be bonded with hydrogen, then only hydrogen bonding happens, right? Only electronegative atom, hydrogen should be bonded to electronegative atoms like nitrogen, oxygen and fluorine, then only hydrogen bonding happens. For example, intermolecular means between two molecules, here one molecule, here one molecule, if there is hydrogen bonding, that hydrogen bonding we call it as intermolecular. H bonding we call it as. For example, I have HF, here HF, hydrogen attached to electronegative atom fluorine, here also hydrogen attached to electronegative fluorine. So it is electronegative, it will be having delta minus, it will be having delta plus. So there will be dipole, minus and plus. Similar here, delta plus and delta minus. So what happens? Fluorine delta minus, hydrogen delta plus. So there will be kind of attraction. That attraction we call it as intermolecular H bonding. Right. But here the question is the intramolecular hydrogen bonding present in, right, A, B, C, D option they have given. We have to tell where intramolecular hydrogen bonding is there, right? So let me draw the structure. First A structure is what? Phenol, benzene ring, OH group. B, orthonitrophenol, benzene ring, phenol means OH, ortho position NO2, right? So C is what? Para-nitrophenol. So benzene, here OH, so it is phenol, para position again NO2 group, N double bond O. And D, para-cresol. Cresol means nothing. This is benzene, this is phenol, para position if I have CH3, it is para-cresol. So P cresol they will write, para-cresol. So A, B, C, D. See, I told hydrogen bonding between, there should be what? HF, hydrogen should be attached to fluorine, or hydrogen should be attached to oxygen, or hydrogen should be attached to what? Nitrogen. But here oxygen is attached to hydrogen. Intramolecular means there should be other one more atom to form intramolecular hydrogen bonding, which is not happening here. So this is not the option. Talking about D, here CH3 is there, here OH is there, no intramolecular hydrogen bonding. Here also see OH is there, NO2, here OH is there, NO2. But here it is para-nitrophenol, whereas it is orthonitrophenol. So in orthonitrophenol, see, can I write it like this? OH, I'll remove this OH like this, I'll make it as H here. So hydrogen attached to oxygen, so delta minus, delta plus. Oxygen is having electron density, so here hydrogen bonding happens. Right, so hydrogen bonding I have told it will be between hydrogen and electronegative atom. So hydrogen is there, electronegative atom, oxygen is there, and this hydrogen attached to electronegative atom. So there it will be delta plus, and this will be delta minus. So it will plus charge will be attracted to this lone pair, and this bonding we call it as H bonding. But this H bonding, see, this is say one molecule, right? Same molecule. This is what? Ortho nitrophenol, right? Ortho nitrophenol. So within molecule hydrogen bonding is happening. So this is example for intramolecular H bonding, right? Are you getting? Intramolecular hydrogen bonding. So here it is happening. So answer is B. You may ask, why sir, this is para nitrophenol, right? Why it is not hydrogen bonding happening? See, because see this OH will be there, right? Like this OH. See here it can't have this much hydrogen bonding because hydrogen bonding is limited. It is distance dependent. If you see if I number it like this, you can easily tell. So see here this hydrogen is 1, oxygen 2, this carbon 3, this carbon is 4, this carbon nitrogen is 5, and this oxygen is 6. So here it forms 6-membered ring. So it is distance dependent, 6-membered ring. But here if you see 1, 2, 3, 4, 5, 6, 7, 8, this much no hydrogen bonding happens, right? So that thing you have to remember. Only it will form 5-membered ring, 6-membered ring. That distance it can easily cover up, right? So orthonitrophenol is forming hydrogen bonding, whereas para-nitrophenol doesn't form hydrogen bonding because of it is more than 6-membered ring, right? Are you getting? So this is the answer. So answer is 2. Talking about the state of hybrid orbitals carbon in carbon dioxide, CH4 and CO3 2-. So first you have to know the structure of those things. So I assume that you know the structure of that, right? So if you have studied chemical bonding thoroughly, you can easily tell the structures, right? So carbon dioxide means C double bond O, double bond O. CH4 means methane, CH, CH, CH and CH. CO3 2- means C double bond O, O minus, O minus. So CO3 1- 2-. So Ca3 2-, right? And one formula. If carbon is having 4 sigma bond, then its hybridization is sp3. If carbon is having 3 sigma bond, its hybridization will be sp2. If carbon is having 2 sigma bond, its hybridization is sp. So these things you have to remember. But this is only for carbon. If I want to talk about phosphor, nitrogen, there is a formula that can be discussed later, which will be very important for JEE as well as NEET. But for CET, just you remember this thing. Carbon with 4 sigma bond sp3, carbon with 3 sigma bond sp2, carbon with 2 sigma bond it is sp. Right? So in carbon dioxide, right, C double bond O and double bond O. So here one bond will be sigma bond, other bond will be pi bond. Here also sigma bond and pi bond. So this carbon, how many sigma bonds are there? 1 and 2. So 2 sigma bond. 2 sigma bonds means how, what is the hybridization? sp. Right. So here carbon, so 1 sigma bond, 2 sigma bond, 3 sigma bond and 4 sigma bond. 4 sigma bond means what is the hybridization? sp3. See, this carbon is there, so this is sigma bond and this is pi bond. So 1 sigma bond, here this is 1 sigma bond and 1 sigma bond. So total 3 sigma bond. So its hybridization is what? sp2. So option if we go through, so sp, sp3, sp2, sp, sp3, sp2. So C is the option. So before going further, I have to tell you something. So in a molecule, only see, it can form any atom. It can be carbon or anything. For example, carbon monoxide is there, 3 bonds are there, only 1 sigma bond will be there, other 2, these 2 will be pi bond, so 2 pi bond. So in any molecule, the carbon will be always, not carbon, any atom will be having only 1 sigma bond. You should not tell between, say here 2 sigma bonds, here 4 sigma bonds. Between one atom and other atom, I am telling, between one other and other atom, there will be 1 sigma bond. See, between these two 1 sigma bond, between these two 1 sigma bond. Here double bond is there, but still 1 sigma bond on pi bond. So always between two atoms 1 sigma bond. Right, sigma bond can be 1, pi bond can be maximum of 2. Alright, so these things you should remember, and other tricks if is necessary you comment it so that I can make a video, otherwise sufficient. Right, so this is about 1 to 5 questions, 1 to 5 questions, and from 6 to 10 questions that I'll release one more video, you can go through that. Right, till then take care and have a great day. Thank you.